Hello, welcome to SparkTalk, where we talk about AI, robotics, and the world of welding and prefabrication. Today, our topic is improving shop flow and the welding process. My guest is Joel Armstrong. Joel is the product manager for Novarc Technologies' flagship product, the Spool Welding Robot. He's a former welding professor and true expert in this field. Thanks for joining me today, Joel. Tell us a little about your background and your role at Novarc.
Sure. Thanks, Pete. Glad to be on. So my background in my professional world has been in welding engineering. Started that way back when. Went to LaTourneau University down in Texas. Got a degree in welding engineering, and then worked various places as welding engineer, fabrication manager, project manager, a couple different things. Left the fabrication side of business and went into sales. Did that for about 10 years, where we looked at workflow, production, process improvement, those types of things. And then just happy to join Novarc January this year. And like you said, I moved into the role of product manager for the SWR.
Awesome. Thanks, man. And you've been a great resource for us, our whole team, and just having someone with your wealth of experience and true welding expert on board is awesome. So it's great to have you, Joel.
Thank you.
So today we'll be diving into the world of shop flow and the welding process. Prefab and specifically pipe fabrication has a big impact on society as a whole. And these shops directly service industries like construction, mechanical engineering, energy, and shipbuilding. And because of the importance and sheer size of some of these projects, fab shops are relied on to deliver, right? And so for the most part, fab shops are 100% controlled environment. And that means people and processes can work together to achieve as close to perfection as possible. But we all know that perfection is almost impossible to achieve. But we also know that people and processes can work against each other, and that can create a poor working environment and negatively impact the bottom line. So in this episode, we will explore the different stages of the prefabrication shop flow with the emphasis on welding and how to make sure operations are as tight and productive as possible. So the 4 steps we're going to be talking about today are mapping out the workflow, identifying bottlenecks, how to assess welding productivity, and determining the true cost of welding. Let's get right into it.
Sure.
So to start, I'll give you a 2-part question, Joel.
Okay.
How would you summarize shop flow, and how does the welding process fit in the equation?
Sure. So shop flow is just exactly what it sounds like, right? It's how do parts go from as raw materials off of that truck through some type of process, welding, machining, cutting, whatever it would be, inventory, and then out of inventory into how are you going to ship it out. So that's really what shop process workflow we're talking about. What was the second part? I'm sorry.
Oh, the second part of the question was how does welding
yes.
Fit in?
Sure. So like I said, welding is really the key part, right? So that's the part where you're going to cut some pipe, your parts, whatever, and you got some piece parts and shapes. You got to weld them together to make that final product. So welding is really one of the key processes in pipe, in pipe shops, fabrication, whatever it's going to be.
Yeah. And so I guess if you could, I guess the mapping out the workflow. So figuring that whole thing out and from I guess you could look at it from a visual point, but so let's just start with the actual workflow of a shop. So can you talk about the life cycle of raw material to finished product? And what are the important things to consider within this process?
Sure. Like you said, we're looking at workflows. That's really the first step. We'll kind of go through a couple other things we're going to talk about. But when we're talking about workflow from a process improvement, you're really talking about a group of people within an organization. It's going to be those continuous improvement folks. Maybe it's production management, maybe it's manufacturing engineering group or welding engineers or operations. They're really going to look at what that workflow is. And when we're talking about it, like I said, we're talking about the physical movement of that material from raw stock to finished product. What is the physical distance it takes? And a lot of people says, oh, it comes in the left side, goes out the right side. But it's what happens in the middle there. How many times do you handle that part? How many times does it travel back and forth past an operation only to come back to, that same operation or place in the shop? My experience, one of the places I worked at, we did this and we physically took a scale drawing, got a huge map that we could lay out on a large table. And we took a couple of different parts and we said, okay, raw material to finished product, where does it go? So we took our routing for that part and we actually measured distance that part traveled. I can't remember the exact number, but it was one of those things we had to report on it in miles. That part actually went miles, and it went from the left side to the right side to the left side to the right side about 6 or 7 different times. And before the process start, you think, oh, well, we probably optimized that very well. When in reality, we had not optimized it. The shop floor was laid out in a certain way, and 4, 5, 10 years later, we've changed the flow of things for whatever reason, and now we're not an optimized role. So really look at that physical distance. Is it yards? Is it meters? Is it miles? Or maybe it's feet, and then you've done a good job. But the biggest thing we're looking at there is part handling. How often are you touching that part and moving it from one process to another? And that is really a non-value added task. So really challenge people to go look at it. Get your scale drawing, or maybe you're able to use a measuring tape or whatever it be. But I'm going to bet you're going to be surprised by the results when you really figure out what that distance is that a single part will go through.
Let's talk about, I guess we could talk about bottlenecks now, because that's probably, one of the biggest problems that a lot of shops have. So I actually just I listened to an interview with Elon Musk, and he talked about the production at his Gigafactory in Austin. And this directly relates to workflow. And he says he doesn't even have an office. He holds all of his meetings in a kind of like a bird's eye glass view of the entire shop floor from like an elevated point. And this is at the end of line production. So if he sees that cars aren't moving here, then he knows there's something wrong upstream. And he's identified this as the most critical bottleneck Tesla has. And that's why he's there, I guess, or overseeing that or observing that. But what would you say are the main bottlenecks of a pipe fab shop?
Sure. There's really kind of, in a pipe shop, there's really 3 places it's going to be, I guess, right? So it's either going to be before or after the cutting process, right? So I've got when I buy the material, it comes in probably a 20-foot length, or maybe it's a 40-foot or whatever that length is, right? It comes in raw material. For whatever reason, I might have to cut it down to a certain size or a certain length, right? So going into and coming out of that cutting operation, I might have a place where those pipes really stack up, right? So if it's before the cutting operation, means I can't cut as fast as I need to, right? If it's after, then whatever process is coming up after that pipe cutting, I can't handle that capacity. So that next stop is probably a fit or a tacking station. So if it's before my fit tack station, I don't have enough guys that can physically tackle that pipe together. If it's after my fitting attack station, it means it's my welding area can't keep up. So really the best thing to do is you go out on your shop floor and look and see where is a big stack of material, or if it's pallets or, stands or racks or however you guys stage your material, where is that big stack at? And that will tell you real quick where that bottleneck is.
Yeah, it's so like simple, but it's such a I love that approach. Is you gotta look right
Yeah.
and
It's it,
yeah, go
the big thing is, right, it's a lot of times it's you're so used to being in that environment, you don't realize that that's a bottleneck. A lot of times it's you're so used to walking past that area of the operation and seeing it. There's those parts are always there. And so if you're not thinking of it as why are those parts always there, it's just those parts have always been sitting there, So
yeah.
you just not you got to think a little bit differently.
Yeah, definitely. And well, I guess it's pretty obvious, maybe, but what can you do to provide relief in these areas?
Yeah, and so there's kind of these four questions you can ask about how to really do that, right? And the first one goes back to what we talked about earlier, workflow. Are the parts stacking up there because they're having to go back and forth and all this different stuff, or maybe there's a problem in that. The second one is really a workforce problem. And that's more of, it's not really the people you have are bad, right? It's maybe they need some skills or some training, or maybe you just don't have enough of them. So, you kind of have to say, is it a workforce problem? The third thing you can look at is what is your machine capacity, right? If I have one machine cutting, is that enough? Maybe I need two. Do I have 3 tacking stations? Is that enough or too much? You really kind of ask yourself, do I need more of those? And if I had more machines, could I get more through? So you really got to kind of ask that question. And then maybe the last one is automation. Is there something that's a repetitive task that I'm using a highly skilled person to do just because he's always done it? So can I automate something and then relocate that guy and put him in a spot where I really need his skill set to help move things along? So those are kind of the 4 things you need to look at. Pete, the really important thing is you have to realize that bottlenecks really never go away. They're just going to move, right? So once you alleviate it from one spot, it's going to move to another spot. And so you really have to realize that I'm not going to solve it once. I'm going to have to solve it again and again and again and again. And that's why it's that concept of always continuously improving.
Yeah, and it's funny how whenever you look at something like this, like a bottleneck, it always comes down to the 3 things: is people, processes, and tools or technology.
Yep.
And how all of them have to really work together to mitigate, I guess, this inevitable problem, right? So great. So let's talk about welding, and this is something that it's in a fab shop. Welding is literally the process that holds everything together.
Right.
It's the process that constructs the end product, right? So that means it's the importance is huge in this process, and what that also means is mistakes can be very costly. And productivity is key in this process. So tell me about the actual welding process, and what are the most important aspects of welding, and how does that relate to shop flow?
Okay. Yeah. So one of the things I like to tell people when we start kind of talking about this concept is, it's kind of sounds cheesy, but companies aren't making money unless that blue light is on, right? Unless that arc is on, I'm not making any money because I'm not putting those parts together and getting them through. So it kind of talks about that concept I mentioned earlier, value added versus non-value add activities. What is a value add activity? Well, it's probably going to be welding, right? It's definitely one. What is a non-value added activity? Grinding. That's a huge one. A lot of times you see places and you see sparks flying and they're grinding. Well, sometimes grinding is necessary, but sometimes it's one of those things where you need to ask, why am I grinding? Am I grinding because I'm using the incorrect process? Do I have my welding machine set correctly? Is there a welding gas mixture that could be used better? Is my fit up good enough? We talk about cutting that pipe, right? Do I have a tool that cuts a nice clean joint so I don't have to grind it? Or am I have something that's older technology and it doesn't cut very well and I have to manually do it? So anytime I have to grind things, that's a non-value added activity, right? So I want to be welding as much as I can. So some of the questions you really need to kind of consider and ask yourself is, what is my arc on time for a welder? A lot of times you ask that and people will tell you, oh, my welders, they're very busy. They weld 8 hours a day. All right. And impossible. Nobody can do that. If you go to the American Welding Society, AWS goes and they'll tell you it's probably closer to 10 to 20%, depending if you're more of a manual, you're going to be close to that 10%. And if you're really an automated place, maybe you're going to be 20. If you're super automated, maybe you're in that, you want to try and be close to 70 or 80. But that's kind of hard to do. Most of the places I've been in my lifetime, we're going to be closer to that 10% than we are 20%. So then the next question you have to ask yourself, well, what does that mean? So that's a concept that's called operator efficiency. So your operator, your welder, he's there for 8 hours a day. What is he doing in that 8 hours? How much time is that blue light of that arc really going? So again, I'm going to challenge you guys to ask your welders to list everything they do in a day. And I mean, everything they do in the day, from the time they clock in to the time they clock out. And what you're going to find is you're probably going to be very surprised all the things they do. Some are very, have to be done, right? They're very legitimate reasons. Some are maybe not as legitimate, but you need to ask yourself, how many things do they list that they do before one of them says welding? One of the places I worked before, we were doing some welder training, and we were talking about this concept, and we had a room of welders, and we asked them to do this. We listed 26 items that they did before one of them finally said, oh, I guess we weld in a day. Right? So how many things are you asking your guys to do, your welders? They're highly skilled welders that you're paying, some good wages, hopefully, too. Are they doing things that are non-value added? All right. So is there a better way to do something? We've always done it that way is not a good business strategy. That's not going to make you competitive and last longer. So you kind of ask those things. What are we asking our welders to do? How often is that blue light on? And maybe is there some way we can alleviate some of those things? And is that automation? Is that new technology? Is it workflow? Those types of things. So something to think about.
Yeah. And it comes up a lot in terms of, staying with status quo can be a detriment, right? And I mean, it's hard to get out of that groove if some of these shops have been doing it for, some of them have been doing it for 50 years, right? And to really look at that objectively is difficult. But thanks for that. That's some great insight. So in terms of I guess this next question is directly related to what you were just talking about. Well, let's talk about the true cost of welding. So everything can be boiled down to dollars when it comes to this. So can you talk about all the things that factor into the true cost of welding?
Sure. So when we talk about the true cost of welding, there's really about 4, maybe 5 things that are going to contribute to that, right? Things like the welding machine that you bought, the equipment. So there's a cost associated with that. You have a welding wire or welding electrode. So there's a cost associated with that. Maybe you have a shielding gas. There's obviously electricity. So those are the four things a lot of times people think about. But in reality, the number one cost in any welding operation is your labor. Okay. You can look at AWS, Miller Electric, Lincoln Electric, ESOB, any of those places, and they go talk about cost of welding. They all will tell you 75 to 85% of your costs directly come from labor. So that goes back to the topic we talked about before, right? It's how often is that blue light on? You're paying that guy for 8 hours. If he welds 10 minutes or he welds 6 hours, he's making the exact same amount of money. right? So that your product cost is going to be changed depending on how much he welds. So, I mentioned earlier, my last role, I was in sales, and some of the things we sold were welding wire and shielding gases. And it's funny to me knowing some of these facts, right? We would go into our customers or potential customers, and they're very concerned about, what's the cost per pound of my weld metal? What's the cost per cubic foot of my shielding gas? And we'd get very excited if, we were a nickel higher or 15 cents higher or whatever it would be. But when you start asking them a question of how much does it cost you to deposit a pound of weld metal, they can't answer that question. They don't know. And they revert back to the filler metal and the shielding gas. But when you start talking to them about labor being that 75 to 85% of that cost, it really opens their eyes. So like I said before, Lincoln Electric, Miller and Hobart, ESOP, they've got some really great tools for calculating what that number is, whether it's through an app they might have, or there's a lot of them, their product catalogs will have a step-by-step process of how to calculate that. And those are some great tools. If you don't know what it is, again, I'm going to really challenge you as a business owner or an engineer or a manager to go figure out what that cost is.
Yeah. And, we live in a very interesting time these days where technology has gotten really, has advanced a lot in the last few years, because steel fabrication and welding has been around since, I guess, the Industrial Revolution way back in the early 90s, 1900s. So what, in terms of technology, what are some of the biggest technological improvements in welding in the last few years? And you're allowed to be biased in this.
So just some general concepts, some general things, right? The first one is welding machines. Like you said, welding for years has been viewed as a very unskilled arcs and dirty and not a high technology industry. When in reality, there are welding machines today that have as much computer technology in them as a cell phone, right? So the things that they have available to them, and when you say, well, what technology does welding machines have? Well, how does that really? Why do they need them? Because it has humans operating them. So everyone's going to weld a little bit different. Everyone's going to move at a different speed or have their torch at a different angle. In reality, if you think about it, it's just a big electrical circuit. And so the more stable I can keep that circuit, the better my quality of weld's going to be. And so that's part of the technology in there. And there's some things they can do with waveforms and for different materials and things of that nature. Which can really take kind of like that C- welder and really turn them into a B- welder, maybe a B+ welder, right? So that's kind of one area. A second one, it's kind of a new industry, but it's welding related. It's this concept of additive manufacturing, where instead of taking a block of material and cutting and machining and then welding things back together, I start with welding and I weld up a part from scratch. So that's something that's really kind of been a huge new industry that we're seeing in welding. And the last one is really the ease of getting into automation, right? Historically, if you wanted to get into automation, it was complex and there was welding programs and codes you had to learn to program that robot. Today, we're seeing a lot more ease of use, whether it's our spool welding robot, very easy to use. There's really no programming involved. It's kind of a point and go type of thing, or some of these roll around carts that the Lincoln Electrics of the world, the Vectus Automation, ESOP, Miller, there's ABB, there's hundreds of these roll around carts today. No programming really is needed as far as code. It's kind of a point and click, and you teach the robot the path you want it to go on. So that really removes a lot of barriers. So ease of automation is a huge thing that's really come in the last, really last 5 years, 6 years.
Yeah. And this next question is going to be, it's a fun one. It's a hypothetical, but if you had a magic wand, like let's say like a God mode cheat code invention that would improve the welding process, what would you say? What would that be for you?
Okay, so this is going to surprise you, right? So probably would be to eliminate all welding. Because really, in reality, welding is one of the worst things you can do to a metal. You have distortion, it changes the base metal properties. So if there's a way to develop a cold welding process, or we talk about that additive manufacturing, if you could develop something like that, that would be the ultimate cheat code, right? If I can eliminate welding and all the problems that come with it, but still make a very sound part, that would be really kind of a neat process to see.
Out of curiosity, is a cold welding process, is that even talked about at all? Is that like,
I mean, there are some, it's kind of sounds funny to say cold welding, right?
Yeah.
Because historically you think of something that's very hot. There are some things that are quote unquote cold, but it's still, you've got to melt the material to get it together. There's some things where what's called friction stir welding. Well, if you think of the old school horizontal mill where you have something rotating at a very high speed. So I never really actually kind of melt the material. I kind of just combine it and mix it all together like you would a cake batter type of thing. So there's some things that are kind of starting to develop to go down that road. It's kind of hard to do, obviously, in a traditional pipe shop, but there's some technology out there that kind of is doing some of those things. Yes.
Awesome. Well, I'm sure Novarc Technologies, whatever that next thing will be in the weeds trying to work it out. And we have a pretty talented, large team here working on the next thing. But anyways, so anything else that you'd like to add? Any resources or tips for our audience?
I think one of the, just real quick, going in that direction is, automation's coming, and it's probably coming really fast, right? AWS estimates, and I've heard there's various numbers and for over the years, but American Welding Society is saying by 2027 there's going to be a 360,000 welder shortage. So how is the industry going to fill that over the next 4 years? And it's going to be products like ours. And there's some other people out there doing some other things, and it is exciting, right? But you're going to have some intelligent welding. It does, we can talk about trade schools and getting people to go into trades and things of that nature, but to meet the need over the next 4 years, it's going to be really hard to do to get people kind of fit through those training programs. So it's really automation is coming. So it's exciting to see what companies like us, and like I said, there's some other people doing some neat things in automation, but that's really where the future is going to be, in automation.
All right, Joel. Well, it's been a pleasure talking to you. You have such a I mean, I really think we should put you like in front of a classroom and record it and sell those sessions or something. Because
sure, yeah,
you're a true welding professor, and so thanks a lot. Thanks for the conversation.
Thanks, Pete. Appreciate it.